start the 3D. ठीक है, तो 3D में हम लोग को क्या क्या चीज़ करना है बताइए, क्या क्या पढ़ना है? 3D ज्योमेट्री, 3D ज्योमेट्री वेरी वेरी इजी। हम लोग का तो प्लेन अभी सिलेबस से हटा दिया है, ओनली वी हैव टू डिस्कस अबाउट द लाइन। शिफ्ट लाइन ही अभी का सिलेबस में है, ठीक है। सो इफ वी टॉकिंग अबाउट द 3D, सो दिस टाइप ऑफ ज्योमेट्री आर देयर। ऐसे ये हो गया आपका एक्स वाई जेड। सो बेसिक तो आपको जानते हैं कि अगर दो पॉइंट के बीच का डिस्टेंस निकालना है तो हम लोग x2 माइनस x1 का स्क्वायर प्लस y2 माइनस y1 का स्क्वायर प्लस में जाता है z2 माइनस z1 का स्क्वायर। वी ऑल्सो डिस्कस अबाउट द डायरेक्शन कोसाइन एंड डायरेक्शन रेशियो। टू थिंग्स आर देयर, डायरेक्शन रेशियो। डायरेक्शन कोसाइन में क्या था? if we have any point P and if we join this line from the here, so whatever it's making the angle with the alpha, beta and with gamma with the z axis, then the value L is equal to cos alpha, y is equal to your cos beta and z equal to your cos gamma is called the direction ratio। और ये वैल्यू होता था x बटे r, दिस वैल्यू इज y बटे r, दिस वैल्यू इज z बटे r। if you want to find out, this is LMN, what it is actually L, M and N। then we also know that the result L square plus M square plus N square is equal to 1, and this is same as you can write cos square alpha plus cos square beta plus cos square gamma, this value is equal to 1 भी है, ठीक है ना? okay, so next we have the direction ratio। direction ratio, direction ratio, so we can say the value is proportional to direction cosine, direction cosine known as direction ratio। so value proportional to direction cosine are known as the direction ratio। fine, let A comma B comma C are the direction ratio, these two we have taken as the direction ratio। so what is the meaning of that? You can say A by L must be equal to M by B is equal to N by C, let us say as K। हमने बोल दिया कि कोई कांस्टेंट वैल्यू है K के इक्वल में आ रहा है। so from here what we can see that this L is equal to K into A, similarly M is equal to K into B and N is equal to K into C। so then L square plus M square plus N square is equal to K square into A square plus B square plus C square, and we have written above only that L square plus M square plus N square is equal to 1, so it will be K square into A square plus B square plus C square, or value of K square is 1 upon what? 1 upon it will be A square plus B square plus C square, and if we try to write, we want to find the value, this will be plus minus 1 divided by root under A square plus B square plus C square। so this is the value we having over here, the value of K, and once you got the value of A, we can write the value of LMN, because L what we have, L we have K into A, K we got as this one, so it will be plus minus A divided by root under A square plus B square plus C square। similarly value of m is k into b, it will be plus minus b divided by root under a square plus b square plus c square, like that. And n is equal to k into c plus minus c divided by root under of a square plus b square plus c square. So these are the things we having over here, element का value. No problem.
No sir.
एक चीज़ और यहाँ पे देख लेते हैं, द वेक्टर ज्वाइनिंग टू पॉइंट्स एंड दिस ऑल थिंग्स, ऑल दो ये पहले ही बताया था. सो वेक्टर ज्वाइनिंग टू गिवन पॉइंट and their direction cosine and direction ratio. So what is their direction cosine and what is their the direction ratio, that we try to write. So if we have a 2 point given to us, suppose this is the first point, this is the second point, point A, let us say x1 comma y1 comma z1, point B, let us say x2 comma y2 comma z2. So what we have here, vector joining the 2 points. If we want to write the AB vector, so what it will be, x2 minus x1 into I plus y2 minus y1 into j plus z2 minus z1 into k. And this is only the direction ratio. So direction ratio we got as x2 minus x1, एक तो आ जाएगा direction ratio, एक वैल्यू हो जाएगा y2 minus y1 और एक वैल्यू हो जाएगा z2 minus z1. So these are the direction ratio. देन डायरेक्शन कोसाइन क्या होता है सर? तो इस सारे वैल्यू को ही हम अभी पीछे सीखे हैं, हाउ टू फाइंड द डायरेक्शन कोसाइन फ्रॉम द डायरेक्शन रेशियो, दैट वी कैन डू ओवर हियर. नेक्स्ट वी हैव द इक्वेशन ऑफ लाइन. ओके, so now see, now what we have, equation of line in 3D. So we have to discuss about the equation of line. So equation of line we can write in the two form. Equation of line we can write in the two form. So अच्छा, first of all you to know in the plane the three different types of line possible. This is intersecting line, one is the parallel line, these two here are the parallel line, and one is the skew line, like that, neither parallel nor intersect, this is the skew line. So equation of line we can write in the two different form. First, when a point and direction vector given, first thing. Second, when 2 points on line given. These are the 2 points we have, 2 cases we have. So first we are writing the equation of line using the first equation of line using a given point and direction vector. So see how we can write. Suppose we are given with a line like that, so we have a line here, and one point on the line it is given, let us say this is the point A, this is the point supposed to be A, that is the having position vector is A. We taking another point P having position vector R, and you know the meaning of R is actually xi plus yj plus zk, that is the any general point on the line xyz. Now we having one direction vector also, so we'll write one direction vector that is the parallel to this line only. Suppose this is the vector, direction vector, vector b. This is, we have the direction vector, that is the vector parallel to given line. Now one thing, so here the point A is given to us, and this P, we have taken the general point. So if we try to write the AP vector, that is the position vector of point P minus position vector of point A. This is the upper AP vector, and you can clearly see this AP vector, this will be join the AP vector and this vector B, both are parallel to each other, and we know that if two vectors are parallel, so we can write one vector as the lambda multiple of other, that is what r minus vector A is equal to lambda times vector B. So what is the value of r from here? This will be A plus lambda times B. So this is the equation of line in the vector form. You must remember this one. This is the equation of line in vector form. यही हमारे पास vector equation of line हो गया. If we want to write this equation into the Cartesian form, that also we can. So now we'll write the equation in Cartesian form. So equation of line in Cartesian form. In Cartesian form, what we have to do here, simply will put the point. Let us suppose we have taken this point P as x comma y comma z, and this point A as x1 comma y1 comma z1, and vector B is the direction vector, that is something A into I plus B into j plus C into k. That is the direction vector we have taken. So if we put all the values, this is the position vector actually, so this will be xi plus yj plus zk plus A means what we have here, it is equal to A. A is nothing but x1 I plus y1 j plus z1 k plus lambda times vector B, that is A I plus B j plus C k. This is the things. Now if we transfer this side, so this will be x minus x1 into I plus y minus y1 into j plus z minus z1 into k, z1 into k is equal to lambda times vector A plus bj, ai है ai plus bj plus ck. So what we can say here, that x minus x1 by a is equal to कोफिशिएंट देख रहा हूँ है ना, यहाँ देखो आई का कोफिशिएंट यहाँ पे क्या है, a है और यहाँ पे x माइनस x1. सिमिलरली y माइनस y1 by b is equal to z minus z1 by c. So this is a nothing but Cartesian equation of line. This what we have, Cartesian equation of line. So this is the Cartesian equation of line. So this so we have written when 2 points on the line given. Second things, when, sorry, that was the 1 point and direction. When 2 points on line given, when 2 points on a line given, very simple, nothing to do more different here. Simply what we will do in this case, so this one. So this is supposed to be one line given to us, and point on the line given, let us mark this is the point as A, given that position vector A1, another point mark as A2, point B, another point P as R. So what was the previous equation of line? That was vector equation A plus lambda times vector B, but in this case this vector B not given, that vector we can write using joining these 2 points. So this vector B, or you can say direction vector, is a2 minus a1 simply. And the meaning of a here, we have taken x1 comma y1 comma z1, and another point B, we have x2 comma y2 comma z2. We'll put all the value over here. It will be r is equal to a1 I नहीं, ये तो कंप्लीट वेक्टर a1 हो जाएगा, प्लस लेमडा टाइम्स ऑफ दिस विल बी a2 minus a1. So this is the, you can say, the vector equation of line in the 2-point form. And when we want to write the equation is Cartesian equation. सो ऊपर का तो चाहो तो सेम भी रख सकते हो, दैट इज x माइनस एक्स वन बाई नीचे हो जाएगा a. अब a की जगह पे यहाँ लिख देंगे x2 माइनस एक्स वन, y माइनस वाई वन बाई बी की जगह पे लिखा जाएगा y2 माइनस वाई वन, z माइनस जेड वन बाई सी का मतलब हो जाएगा z2 माइनस जेड वन. सो दिस विल बी आवर द कार्टेशियन इक्वेशन ऑफ लाइन इन द 2-point form. So this is the Cartesian equation of line in 2-point form. यहाँ पे एक बात और नोट कर सकते हैं, that if two lines are parallel, अगर कोई दो लाइन पैरेलल होगा तो कैसे निकालेंगे सर? तो दोनों का जो डायरेक्शन वेक्टर अगर है, बोथ मस्ट बी पैरेलल. इट मीन्स यू कैन से लेट दिस इज द डायरेक्शन वेक्टर हियर, दिस इज हियर. सो b1 सपोज टू बी a1i प्लस a2j प्लस a3k, और इसको b1 के फॉर्म में ही मान लेते हैं, ज़्यादा अच्छा होगा. सपोज टू बी दिस इज b1 इंटू आई c1 इंटू के. वेक्टर b2 भी हैव a2 इंटू आई b2 इंटू जे c2 इंटू के. सो इफ टू लाइन्स आर पैरेलल, ध्यान रखिएगा, इफ b1 इज पैरेलल टू b2, मीनिंग व्हाट, द कोफिशिएंट रेशियो मस्ट बी सेम, दैट इज a1 अपॉन a2 is equal to b1 upon b2 is equal to c1 upon c2. So if two vectors are parallel, then the coefficient of their ratio must be same. Second, if two lines are perpendicular, if lines are perpendicular, then their dot product will be 0. So suppose this is the line L1, this is the line L2, direction vector here b1, and here direction vector we have taken b2. Very simply in this case, v1 vector dot v2 vector, it will be 0, and v1 vector if you want to put, it will be a1 क्या हो जाएगा, a1 a2 plus b1 b2 plus c1 c2 is equal to 0. So this is the condition for two lines to be perpendicular. Clear है? So this much for today. Homework by this, so you have to complete the vector you have to do completely, vector full all, and then 3D you have to do first two exercise. I think this only given also. So only the things you can leave, that is the shortest distance का क्वेश्चन आप छोड़ सकते हो, वो नेक्स्ट क्लास में करेंगे. ओके, so this much you complete. After this